I got a nice question from one of our viewers, I believe named Andrew. So Andrew had a question about this particular exercise where we printed a string to the screen. We printed the word apple. And Andrew was going through this and he noticed correctly that here we have opcodes that are part of the 6502C instruction set. But here we have this thing, like we have a label called data, and then we have something that looks like an opcode, hex, and then we have some stuff here. And he was saying, like, if I check this in the mini assembler, in the system monitor, I just don't see it the way that it's put right here. So how do I map this to the processor set of opcodes? So let me show you. So first of all, if we assemble this thing, you see this is now on memory address 0300. So let us get into the system monitor. And then if we wanna check this memory location, we come here and we have a bunch of bytes in here. But let's say I want to disassemble that. So I want to see what are the assembly instructions that are on location 0300. So I say 0300L as in list. And then we have the disassembled version. So on 0300 we have load X with value 00, which is exactly what we've done here. And then load the A register with 0313. You see, this is what we're doing here, but in this case, this address, this memory address 0313 is the address that gets replaced by this label. So actually, when we use the data label here, we're saying we load the accumulator with this position with X. So we're loading the X register with the contents of the address data. And the address data is here. And looking at the disassemble, we know that data is 0313. So we can actually check at 0313 and then we see some stuff in here, but that's disassembled to compare D0X branch not equals blah, blah, blah. And I don't see any of these instructions on my original program. So how come? So what happens is that we asked the system monitor to disassemble the program starting in this memory location, and it did the right thing up to this point where you have this return subroutine here, which is this one. So up to this point, this is actually what we wanted, right? So up to address 0312, this is exactly the assembly program that we have here. However, starting from this point, what we have is data. So this is a string. This is just a sequence of characters. So C1 is the character A in hexadecimal. So you see the A here is this C1. So we're putting this byte here with the character A, and then D0 is the hexadecimal code for the character P. And then you have another D0 because we have, So we have another D0 because we have two P's in Apple. Then we have CC, that's the L. Then we have C5, that's the E. So we are just putting what we're telling here, the Merlin assembler is to take this data, treat it as a hexadecimal, set of hexadecimal data elements. In this case, they mean characters. I mean, we could treat these things as numbers, whatever. It's just we are putting C1, D0, D0, CC, and C5 in memory location 0313. And then we are referring to this memory location 0313 as the label data. So when we do this, we are basically pointing the accumulator to start printing the A. And then, as we saw in the lesson where we discussed this particular exercise, that we have a loop, and in this loop we are traversing and loading each character one at a time in the X register, and using that to by using this particular subroutine to print one by one to the screen. So this hex here is not an opcode. This is what the Merlin assembler calls a pseudo-op. It's not an operator, it's a pseudo-operator. So it's in the same place as the operator, but actually this is not meant to be translated into actual opcodes of the processor instruction set, but it's meant as just a hint to the assembler that it should treat this set of things here as being hexadecimal numbers. So it knows, okay, every two of them, it's basically defining a different byte that I put in memory. So Andrew, I hope this sheds some light into the matter, and let me know if you have other questions. Thank you.